Now, we already discussed about the definition part of the logic gates.
Okay.
So, what is logic gates? Basically, logic gates are used for making logical decision. Just silent. Making logical decision inside the computer. Means anytime whenever we want to make any logical decision, we just use the logic gates. Now, by the help of various logic gates, the logic circuit is designed. Then, what is logic circuit? Logic circuit is the circuit in which various logic gates are used. Means whenever we are designing any circuits, then in that circuit we are using logic gates. Now, why we discuss logic gates? Because we are in the process to discuss about the combinational circuits, which is responsible for designing inside the computer for functioning of various operations. Like inside the ALU, we have various types of circuit, and that circuits are known as combinational circuits. How that circuits are designed? That circuits are designed by the help of logical gates. So once we discuss about the logical gates, then we are in a position to generate a combinational circuits which exist inside the ALU. Now, today we will discuss about various types of logic gates. Under various types of logic gates, there are three sections, that is basic, universal and additional gates. Now, under basic gates, there is AND gate, OR gate, NOT gate. There is two universal gates, that is NAND and NOR. Two additional gates in the form of XOR and XNOR. Why it is additional gates? Because these gates are designed by the help of basic gates. That means all the basic gates AND, OR and NOT, it is used to design of XOR as well as XNOR gate.
Combination of NOT and AND.
Yes, whenever we think about the universal gate, it is the combination of NOT and NOT OR. That means in the case of universal gates, NOT gate is the common gate, and OR is in a uniform. Whenever we have to design NAND gate, then we use AND with the NOT, and whenever we design NOR gate, we just use OR with NOT. That means NAND gate is nothing, it is the AND gate followed by NOT gate. After discussion of all gates, you are in a position to design any combinational circuits. That is the first section of the digital circuit. Now, one by one we discuss. Now, whenever we discuss the particular gate, we just discuss the gate on the basis of some characteristics. What are that characteristics? The four main characteristics of any logic gate. First of all, that is the logic symbol. What is the logic symbol we have for the specific gates? Then what is the logic expression? These are the characteristics of any logic gate, not for a specific gate. Whenever we discuss any logic gate, then we discuss the characteristics of a specific logic gate. Characteristics of logic gates. So we just discussed the logic gate on the basis of these characteristics. That means all the logic gates are differ on the basis of these characteristics. Logic symbol, logic expression, then we have a truth table for each gate, and there is some conclusion on the basis of which the output is generated in a specific logic gate. Now, these are the characteristics on the basis of which we differentiate each and every logic gate. Earlier in the previous class, we already discussed about the way to generate the input combination. Now, whenever we are generating input, we are generating input on the basis of number of, we are generating the input row combination on the basis of number of input we have. That means we already discussed that for n number of input, total number of combination, total number of input combination is 2 to the power n. We already discussed this part in the previous class. So whenever we have to set the input row combination for the specific set of input, then we just consider this section. That means if there is one input, 2 to the power 1, that is 2 input row combination we have. If there is 2 input, 4 input row combination we have. This is common for all gate. Means whenever we are thinking about the input section of the gate, because whenever we think about the truth table, we have to represent the data in the tabular form, and that tabular form is nothing, it is the input and output column. So there is some column for input and there is some column for output. For generating the input column, this is the particular section. For any gate, whenever you are in the process to generate the column for input, you have to think whether what is the value of n you have. Means if the gate is using single input, 2 combination of input row you have. If the gate is using 2 input, then 4 input row combination you have. And that is common for all gate. Any gates in which you are taking input consideration, that consideration should take place on the basis of this condition, that is n number of input generate 2 to the power n number of input combination. Now, how the output, this is the very much section on the basis of which the output is differ from one gate to another gate. So we have to concentrate on the conclusion part whenever we discuss the particular logic gate. Now, one by one we discuss. First, AND gate. Note it down. Yes, it may be written in EXOR or exclusive OR also. You can write it exclusive OR also. Exclusive NOR also. That X stands for exclusive. That means it is also represented in EX OR. Here EX represents the exclusive. That is exclusive OR. Now just start. Now whenever we are in the process to define any logic gate, then we just think about the definition of the logic gate. Now when we define the logic gate, at that moment we just give the definition on the basis of the input and output ratio. What we have to add in this particular definition, we have to add the conclusion part. What is the conclusion on the basis of which the particular gate is generated output. What is the conclusion for generating output in a specific gate? We have to take proper consideration whenever we are writing the details about the particular gate. Rest definition remains same. That means in definition of any gate, we just use there is a 2 or more than 2 input and only 1 output. That means that is common only for except for the exception is for NOT gate, because in case of NOT gate, single input is there and single output is there. Now whenever we thinking about to discuss about AND gate, OR gate and NOT gate, just before discussion of that, imagine the various arrangement of the current flow. Because once you discuss that thing, then to find out the conclusion part of AND gate, OR gate and NOT gate is very much easy to you. Now there are 2 ways. One of the way is where we are arranging the current flow in series manner, and there is another way in which we are arranging the current in parallel manner. There is 3 switch. This one is the parallel. Now whenever we discuss about the AND gate, just consider what is the output conclusion of AND gate. Just for AND gate, consider this series arrangement of current flow. Means in series arrangement of current flow, this bulb is on only when all the switch is on. If any of the switch is off, the bulb is not going to on. Now in this case, this is equivalent to which? This is equivalent to AND gate. Now whenever we discuss OR gate, you just imagine the current flow in the parallel way. That means either of the switch is on, then the electric circuit is completed, and once the electric circuit is completed, then this bulb is on. So this is the scenario for OR gate. In case of NOT gate, we are just using the example of inverter. In inverter, when power is on, battery supply is off. When power is off, then battery supply is on. That means in case of, yes.
If any switch one on, then current supply is passing or not?
Speak loudly, speak loudly.
If any switch is on,
yes,
in OR gate,
yes,
then current supply is passing or not?
in this case, if any switch is on, the current supply is completed. and bulb is on. In case of OR gate, we are doing the same job. Means if any of the input is high, output is high. That is, in case of gate, we are using 1 and 0, 1 for high and 0 for low. So in this case, whenever your bulb is on, that means output is high. And whenever your bulb is off, that means output is low. So in case of parallel, if one of the switch is on, out of 3 switch, if one of the switch is on, the circuit is completed and bulb is on. But in this case, if to complete the circuit, we have to put on all the switches connected in between this bulb and this battery. That means, in case of AND gate, what is the conclusion? Sit down. In case of AND gate, yes. In case of all switch on, the bulb, no issue. Still bulb is on. If all switches is on, no issue. If one switch is on, there is no issue. Then if all switches are on, there is also no issue. That means you are arranging the switch on different floor. That means you at your home, you are maintaining 3 switches on each floor. So that like two-way switch you are using. If you put on the particular switch, your bulb is on in that particular, because you are arranging the particular flow in parallel manner. 3 parallel switches are there, and one of the switch is on, then current flow is completed and bulb is on. So why I discuss this thing? Because you have already concept of the electrical circuits in physics. Now in AND gate, whenever you considering the AND gate, you just think about the series arrangement of current flow. Then whenever you are thinking about the series arrangement of current flow, it is very easy to find out the conclusion part of the AND gate. Now only you have to think about the high and low output. Whenever your output is high, that means it is represented by 1. Whenever your output is low, it is represented by 0. That means, how we can define the AND gate? Just mention, it is the logic circuit. Yes? Yes. That's why in case of AND gate, output is high when all its input is high. That is the conclusion part. So in AND gate, it is the logic circuit having, because in AND gate, you need at least 2 input. So we just change the definition, which is earlier we are taking 1 or more than 2 input in case of logic gate definition. Because in logic gate we are considering NOT gate also. In NOT gate, single input is responsible for generation of output. But in case of AND gate, at least 2 input is needed. So whenever we are in the process to defining the AND gate, OR gate, or any other gate except NOT gate, then always we have to take at least 2 input and 1 output. That means it is the logic circuit having 2 or more than 2 input, but only 1 output. Now in the definition of logic gate, we already discussed that here the output is represented by 1 when it is high, and it is represented by 0 when it is low. So no need to mention that particular sentence again for each and every logic gate. That is automatically adhere with the particular gate. So it is the logic circuit having 2 or more than 2 input, but only 1 output. Now we think about the second sentence. You have to write about the conclusion part. So what is the basis of output generation in case of AND gate? Now whenever you are in the process to write the conclusion part, you think about the series arrangement of current flow. In this case, whenever any of the switch is off, the output is off. That means output is low. Here we are using high and low. For off we are using low. For high we are using on. For on we are using high. So what is your second sentence? What do you think? It is the logic circuit having 2 or more than 2 input, but only 1 output. What is the, yes, first of all we define, then after we discuss the characteristics of all gate. So first is the definition. First sentence is clear to you. It is the logic circuit having 2 or more than 2 input, but only 1 output. That means whenever you are in the process to design the truth table, you have to consider the input as well as output, because you have to represent the relationship in tabular form. Yes. So what is your next sentence? What is your next sentence? Next sentence is the conclusion for the particular gate. So how you can write the conclusion? Output is high when all its input is high. So second sentence you write output is high, that is 1 when all its input is high, otherwise output is low, that is 0. That means just imagine the series arrangement of current flow. In this case, all the switches is on, then only the bulb is on. That means when the all switches is on, input is low or high. Whenever the switches is on, input is low or high. For all switches, input is high.
Yes.
That means whenever you are using 3 switch, all the 3 switch must be in high position. That means in on position. If you are using 2 switch, that is what? Switches are nothing. Switches are the number of input.
Yes, sir.
Here we are using 3 input. Whenever you want to use 2 input, you just attach 2 switch here. To complete the circuit, you have to put on all the switches. Now on position is the high position or 1 position. Yes. Any query?
Symbol regarding the symbol.
Yes.
Regarding symbol.
I just come after completion of the definition. I just discuss the characteristics. So it is the logic circuit having 2 or more than 2 input, but only 1 output. And what is the output conclusion? Output is high, that is 1, when all its input is high. Otherwise, output is low, that is 0. Now we discuss the particular gate on the basis of characteristics. So what is the first characteristics we have to discuss? That is the logic symbol. Now what is the logic symbol for AND gate? You just see. For any 2 Boolean variable AB, this is the logic symbol y equal to A dot B. Second characteristics, right now we are discussing AND gate. Where is OR gate and NOT gate? Right now we are discussing AND gate. So this is the symbol of AND gate. We are discussing the characteristics of AND gate, because after definition of AND gate we are discussing the characteristics. So no need to say whether it is OR gate or AND gate. So this is AND gate, logic symbol of AND gate. This is the logic expression. Whenever you are enhancing the input, then the input channel is only change, and what is change occur in the output channel? Like for 2 input A dot B, for 3 input, suppose third input comes in the form of C, so A dot B dot C. In case of 4 input, A dot B dot C dot D. So that become your logical expression on the basis of number of input. Right now we are giving the logical expression for 2 input. Whenever you are changing the input, number of input, then at that moment you have to change the expression as well as number of input in the logical symbol also. So this is your logic expression. And then we discuss the truth table. Now how the truth table is designed? The truth table is designed by the help of input and output. Just think about input first, because for output we have already consideration. There is a conclusion for output. So once the input is completed, you can easily allocate the output on the basis of that conclusion. So because in truth table we consider for n number of input, here number of input is 2. So just mention here n is equal to 2, therefore total combination is 4. That means whenever you are in the process to generate truth table, you have to think about how many number of inputs we have. So here in this case we are taking 2 inputs in the form of A and B. That means number of input is 2. How many total input row combination we have? 2 to the power n, that is 4. Then make Now make column for input as well as output. In input column, we have to maintain 2 columns. In the previous class, we already discussed how we are taking input on the basis of number of input. Yani how we are taking number of input row combination on the basis of number of input. Because here number of input is 2, then total number of input row combination we have 4. That means how we are generating that input row combination? Yes, you have already concept that we are working on the basis of binary number system, the digit of binary number system. And in that number system only 2 digits are available in the form of 0 and 1. So we don't care other digit than 0, 1. We just use only 0 and 1 in case of truth table. 0 is the representation for low, 1 is the representation for high. Now, input combination is common for all gate. Whenever you are writing input row, then it is not for AND gate only. What is the difference? Whenever you put up the output column, and whenever you are finalizing the output column, that treat that particular truth table differ from the another logic gate truth table. Now, first of all, 4 combination, then what is the half of the 4? 2. That means 2 times 0, 2 times 1. And what is the half of 2? 1. That is 0, 1. Now, after writing this, you have to think about the conclusion part. What is the conclusion? Conclusion is output is high whenever all its input is high. Now, after reading this section, now whenever you go through that conclusion part, it is very easy to allocate the output section, but before allocation of the output, you just mention the expression for this one. Y equal to A dot B. Now I think it is very easy to allocate what is the output, because this is the only condition where the output is high. In rest cases, your output is 0. Yes? Yes. How we are taking input? In the last class, in the previous class, we already discussed that one. Don't discuss. That means on the basis input, let's see, consideration of input row. We already discussed about how we considered the input row. Your input row is considered on the basis of number of input. So for n number of input, total combination is 2 to the power n. So we already discussed, suppose for n equal to 1, we have to make because for n equal to 1, 2 to the power 1, that is 2, half of 2 is 1, that is 0 and 1. Similarly, for n equal to 2, we have to maintain 2 column. Now see, for n equal to 2, total combination is, here the total combination is 2. That's why we are maintaining 2 input row. For n equal to 2, we have to maintain 4 column. So what is the half of 4? 2. Half of 4 is 2. For first column, we take the half of the total input row. For second column, we just take the half of the another one. That means half of the 4 to maintain first column, half of the 2 to maintain second column. So I think that input combination, yes.
So in first truth table, it might not be considered AND table.
In first?
AND table look at.
Yes. Repeat the question. I do not repeat the question.
He said that it is not considered in AND table.
Right now I am discussing the input combination. In which manner we are taking the input. When we allocate output, then we consider the output. Yes. What is your question? What is your question? Repeat it.
सर वो AND में नहीं होगा, वो एक ही इसलिए बोल रहे हैं.
Whether I say that it is implemented for AND gate, it is only implemented for NOT gate. Silent. That's why I am changing the definition. Whether I mention here 1 or more than 1 input, I mention here 2 or more than 2 input. That is not applicable for AND gate. It is quite clear. No need to ask. Yes.
Take n equal to 3, sir.
N equal to? Yes. When n equal to 3, it is already discussed. But see here. When n equal to 3, or n equal to 3, you have to maintain 3 input column. Now, whatever process we are doing for single input, for 2 input, same process is repeated for 3 or for n number of input also. So here in this case, total number of input is 3. Then what is the total combination we have? 8. Now we have to maintain 3 column. What is the half of 3? Half of 8? So first, for fulfillment of first column, we just take 4, 0, and half of 4 is 2 times 0 alternatively. And what is half of 2? Now the concept is clear. Now after completion of this truth table, suppose the fourth part you have to write the same, whatever conclusion we are mentioning in definition. So what is the yes?
You are not in the frame. No need to in the frame.
Means?
फ्रेम में नहीं आना था, लिखना है कहीं और बुला रहा है।
अच्छा नहीं just arrange it. Means board is visible or not?
Crystal clear.
Okay. I am not visible. Board remain to be visible. Whether I am visible or not, that doesn't matter. ठीक है ना? No. You are on live session. ठीक है ना? You are in offline. Just set it. Silent. Just set it down. Because I am not seeing from that location. Just put up the camera in my focus.
Did not worry about his placement.
Okay. This one is clear or not? Okay. Now, select. Now, let me complete, then I just clear your confusion. Here we mention output is high. Yes, when all its input is high, otherwise now this is the fourth characteristics we have to discuss about that gate. Now this conclusion is not for two input. This is valid for any number of input. Now after completion, I just give you one problem in which you just give me the details of each and every characteristics. That means in place of two input, you have to design the logic symbol, truth table, logic expression, because the conclusion part same. The conclusion part for all number of inputs, for two number of inputs, for 3, 4, or for n number of inputs remains same. That means output is high only when all its input is high. Now, yes.
I wrote the conclusion in quotes. I wrote the conclusion in quotes.
Just to focusing on that, or there is no reason behind that. If you do not want to focus on that, you just delete that double quotation. No need to. Yes. Now, write the question. Note down the question.
Yes, sir.
give the logic symbol. Now note down the question. Give the logic symbol, comma, logic expression, logic symbol, logic expression, and design the truth table, for 4 input, just mention in this manner, 4 input AND gate. You can take A, B, C, D, X, Y, Z, but if you are taking X, Y, Z, then don't assign that expression in Y. You just change the variable for that. Okay. Now you have to mention 3 characteristics, because conclusion need not to mention, because conclusion remains same for any sort of input. Now you have to check out for 3 characteristics: logical symbol, logical expression, as well as the truth table for 4 input AND gate. Now whenever you are writing the name of gate, just write the name of the gate in capital letter. Don't write the name in sentence case, because it represents the specific. Yes, do it. Then what is the change occur whenever we thinking about that? First logical expression will be changed. Yes, you can do. I am not going to solve this one. First you complete, then I discuss. Completed?
Hold on, sir.
ठीक है ना? Now you have to discuss the characteristics on the basis of 4 input. Now first of all you have to think about the number of input row combination, because output section is very much easy once the conclusion is okay for you. Yes, completed. Done. Okay. How many input row combination you have? 16. And it is very much easy to allocate all 0, 1 whenever you have to maintain 4 columns. Now in this case, total number of input row combination is 16.
Sir, check it whether it is right. Obviously you have negative.
Yes. So whenever you are designing the truth table, in that moment, for maintaining first column, what is the half of 16? 8. That means 8 times 0, 8 times 1.
Yes.
Now for maintaining second column, half of 8, that is 4. This one is correct. Correct. Yes, yes. Only one output comes in one form in the last column, last row. Yes, yes, correct, correct. Yes, correct. Okay. It's okay. Yes, correct. Signature. Okay, I just give you the signature. Just take it. It's okay. Just come to this one. Just check it. Now in this case your number of input is 4. So here 16 input row combination you have. Now I am not going to design the truth table. You can easily draw it. Yes. Okay. Now second one is the OR gate. Now next we discuss about, don't discuss. Next we discuss the second basic gates, that is the OR gate. Now, whenever we discuss the OR gate, the first sentence remains same. That means the definition like AND gate, here also we need at least 2 input. Not less than 2. We need at least 2 input in case of OR gate also. So number of input is 2, at least 2. But output is 1, that remains same. What is changing in this case? The output consideration. That means,
Even a single one is
yes. Whenever we are thinking about the conclusion part of OR gate, we just imagine the parallel arrangement of current flow. In case of parallel arrangement of current flow, if either of any switch is on, then the output is on, that means bulb is on. So what is the conclusion part of OR gate? What do you think? Anyone? Yes, Anand Kumar.
plus expressing
No. Don't make noise. If we are thinking about the conclusion part of OR gate,
If any condition is
you can
output will be high, if any
also do the paraphrasing. Yes. Yes, output is.
output is high, when any input is high.
Yes, correct.
if any input is high, output will be high.
Yes, that means in this case paraphrasing occur. The way of writing the particular conclusion changes, vary, but the outcome remains same. Means the statement remain maybe vary, but the output remains same.
Only once it will be
So you can say, in this case output is high. Just give the conclusion part on the basis of high or low. Whenever it is high and whenever it is low, either you select high or you select low, and on the basis of that the paraphrasing, the sentence will be changed. Now whenever you are considering high output, that means when output is high, when one of its input is high. At least one of its input is high. For generating high output, there is need of one input high. So when we write the definition, just write the definition.
this contribution.
Now, in this case, it is also a logic circuit having two or more than two input, but only one output. And in this case, output is high, that is 1, when at least one of its input is high, otherwise output is low. Means this is this second line is the conclusion part of the OR gate. That means whenever you are in the process to generate the output for any number of input, only you have to consider that line. That means it doesn't matter ki number of input is 2, 3, 4, 5. Output always remain high when at least one of its input is high. Okay. Now we are considering here only two input. Yes? Yes, A plus. Here plus symbol is used for OR gate. So logic symbol is what? We are discussing the logic symbol, logic expression for two input. Yes, we are considering n equal to 2.
Okay.
So whenever you enhance the number of input, you have to perform enhancement in logical expression as well as in truth, in logical symbol also, as like in AND gate. Why you are laughing? Now, for generating truth table, you can generate it. How you can generate the truth table?
Yes. We can, in last, we can considering at least one
It's saying triangle or
Curve. This one. Now, again, whenever you have to consider the input, the same process you have to perform. And number of input row combination is 4 because number of input is 2. So half of 4 is 2. That is 2 times 0. And half of 2 is 1. Now to accomplish the output section, you have to think about the. Just think. Whenever at least 1 is there, output is 1.
Yes. Only output.
And the fourth section, you just write the second sentence, that is the conclusion part. The output is high, that is 1, when at least one of its input is high. Now again, write one question. Just after completion. No, right now you have to. Yes, this one is the classwork. Yes, 3 input OR gate. You have to design truth table, logic expression as well as the logic symbol for 3 input OR gate. Question is mentioned on the board. Just note it down. Now you are also live. 1, 1. Why it is 2?
1, 1.
Don't perform addition or subtraction here. That means if there is 2, 1, just output is 2. We are not doing the addition job here. Plus is used for logical OR, not for arithmetical OR. Arithmetical addition operation. Now it is correct. Yes. Yes, just check it. In the first column, first row only the output is 0. In the rest of the row, the output is high. That is 1 because in the rest of the cases, at least one of the input is in the form of 1. So whenever your input is, at least one of the input is in the form of 1, output remain high. So this one is the correct. You just check your own also. Yes, correct. Yes, correct. Yes, correct. Now only you have to change here. Only you have to change here C as a third input and y equal to a plus b plus c. Now logic expression becomes y equal to a plus b plus c, because here number of input is 3. So we have total 8 number of input row combination. Now this one is visible or not? Yes. This side? Yes. So now in this case your number of input is 3, so total 8 number of input row. So what is the half of it? 4 times 0, 4 times 1, and what about half of 4? That is 2. Half of 2. Okay. Now this is the only case where output is 0. In rest cases that means the first row contains the output high, low. Rest of the row contains the output high. Achha, after class. Now, can I rub it? Now the third one is the not gate. Now this is the only gate in which single input. This is the only gate. Why you are laughing? Not concentrating inside the classroom. If you are not comfortable over there, come sit on the first bench. Yes, silent. Now, this is the logic circuit having one input and only one output. That means in case of NOT gate, single input is there, a single output is there. That means whenever, yes, that is the complement. Any output is complement to the input. So if your input is low, output is high, and if your input is high, output is low. And in this case, there is no option to generate the circuit using more than one input. This is the only circuit, this is the only gate in which we are taking single input, and single input is responsible for generation of single output. So what is the output conclusion for this? That means the reverse process will be same. The output is high, that is 1. When input is low, that is 0, vice versa. That means the output is low, that is 0 when input is high. Your output, in other manner you can say, the output is complement of input. In case of inverter, your output is complement of input. Any whatever input value of you have, the output is just complement of that one. So if your input value is 0, output is 1. If your input value is 1, output is 0. Now, Now the logic symbol in this case is, now on the basis of the last sentence, the output is complement of input. We can write in this manner. If the input is A, output is complement of A. So what is the logic expression? Here there is no option for changing the number of input. Yes?
After triangle.
Yes. That is the bubble. Yes. For not representation of NOT gate.
So we can call this switch or not?
No, this is not switch. This is not switch. This is included with the diagram. This is not. This is a part of the diagram.
Sir, what should we say? Triangle with
Triangle with bubble. You can say same bubble is used whenever you have to represent this NOT gate along with any gate. Suppose if you place here, that means this NOT gate is along with AND gate. So this bubble is placed to represent the NOT gate also. Now in this case, number of input is 1. So what about the truth table? Now, number of input is 1. So how many combination we have? 2. That is half of 2 is 1. 0, 1. So complement of 0 is 1 and complement of 1 is 0. As per the output conclusion we have. In output, and the fourth characteristic, just mention the conclusion part. Yes, that is the fourth characteristics. Right now, only 12:15. In next class, we will discuss about the universal as well as additional gates. Just stop the process. Off किया ना?
ऑफ तो है सर मैं सर
It is for camera ना? This one is for smartphone.
ऑफ भी लिखा हुआ है इसमें ऑफ
Off for